All right, just to wrap it up. So two things that are important for tomorrow. Again, tomorrow is marking. I will send a Blackboard message later on, email. And the idea is there that we do the marking in class. So if you have any comments regarding your second assignment, so something that is either an issue in GitLab right now or something we haven't attended to yet and so on, or something you just want to highlight, tomorrow is the time to do that. At the same time, we'll also mark assignment 3. So for assignment 3, ensure that your group is present here because we do it here. We don't just want to evaluate your system purely functionally, but we also want to talk to you and ask certain questions about, you know, how you developed it, introduce us to the architecture and deployment aspects, because deployment is one thing that's more important in this particular assignment. So ensure to be here in ideally both sessions. So we have the morning session at 11 a.m. and the afternoon session at 4 p.m. Of course, if you are done in the first session with marking, you don't need to, you know, return for the second session. So it's a bit, bit ad hoc, admittedly, but since there's a lot of groups with self-assignments, so people actually shuffled around and optimized their groups, we no longer have a coherent overview, so we can't really plan the groups anymore. That's the downside, lesson learned. But so you guys, you just need to attend, but you can still, you know, either work on some other aspects or do other coursework or the like, so it's no harm. And we hope to make it reasonably efficient for everyone.
And it is important to understand that tomorrow we have to set the marks for the assignments. So after tomorrow there is no more fixing or helping or anything with the assignments. Yep. Because we actually are 1 week late to submit the grades to the examination office already for the internal assignments. We're supposed to do it 2 weeks before the exam. And they kind of grumpy at us that we don't do that, but you know, we will do it on Wednesday, so then please come tomorrow and complain or talk with us about the grades. The essence for the stream, there's no more exceptions, extensions, or anything else. So even though we're very giving in this course in particular right now, in this iteration, there's simply administrative constraints will prevent us from doing so. So tomorrow is final. If you send me an email on Wednesday, say, hey, sorry, I wasn't there, I need to be marked. Yeah, I'm happy to mark you, but you still won't help you because you won't see that mark in your assessment anymore. Yeah, needs to be clear. Tomorrow is marking time, and needs to be clear to everyone. Cool, sweet. Questions, worries? So bring information about assignment 2 and obviously assignment 3. Both of those are subject to marking. Okay. Apart from doing that, a minor Kahoot just to keep the attention somewhat here, because it's a bit of a dryish review lecture. Apparently, has everyone been able to log on so far? Here's a Kahoot. Please, is everyone logged in somewhat? Yes, no?
The username was taken.
Are you joining?
I'm joining, of course.
Yes, go for it. Okay. Bit more code injection here. Further creativity is 28 players. Oh, real name. Using your real name. Okay. Anyone else? Cool? All right, we go. Okay, 12 questions. Are you ready? It's not many questions, not very hard, but it's just being fast. Oh.
No. Be precise.
Yeah, so be precise. Okay, what is POSIX?
Easy.
That was too long. I need to be faster.
Yeah.
It's hard to read.
Cool. Okay, most people got it right. So we talked about this very early on. What does this POSIX thing mean? What does it mean in practice? Yep.
That I can type ls into any terminal and it will do the same.
That's right. So you have a largely uniform terminal, for example, terminal interaction. So that's one part of the POSIX specification, is how you deal with the shell, right? With the operating system, with the kernel. So the tools are uniform. You find increasing moves towards that again, even in Windows operating systems, but most commonly found in Linux, Unix, BSD style systems, right? So everything you learned about the command line here was reasonably POSIX compliant, so you can actually expect to use it in any cloud-based environment. Implicitly, most cloud-based systems work on Unix or Linux basis, therefore POSIX is relevant. So if you come across that term, you know what it roughly stands for. It's an incredibly long and boring specification about various aspects of operating systems, but the ones that are very interesting for us are really file system structure, for example, process management, and the command line interaction, I guess. Okay, next one. Oh, wow. Okay. Big Daddy. Cool. All right, another try. It's too long. It's too long.
Well,
It's all right?
it's all right.
Not rushing? Okay.
No rushing. Yeah, we've discussed the Kahoot with Simon and students before, that the balance between the speed and accuracy is not well balanced in Kahoot. It really promotes the speed.
Yeah.
So
I know we talked about this. Yes. So, but what I want to get is the intuition. So, cool. So it seems like collective intelligence still goes towards the right thing here. So it's 204, right? So it basically, who hasn't dealt with that status code in their code somewhere?
Who hasn't? Or
Who has not? Yes.
we used partial contact.
Okay. Yep. So, yep. Again, we didn't require hard standards. We kind of asked you to come up with good status codes.
yeah, so what's 500?
Ah, yeah, what's 500? Let's run through those.
Internal error.
Internal server error.
Yeah, so
Yeah.
server-side
When-
error, right?
When do you usually use it?
When something goes wrong on the server side.
Exactly.
Exactly, in your server.
When the server side makes a mistake, not the client side, right? You don't use that code, you don't use 500 enough if it's a client side problem, right?
Yeah, cool.
So 404,
404?
Client side problem.
client side problem.
Yep, well, yeah.
Not found.
Yep.
That's right. Cool.
404 we know, and 302.
Missing or something. It's a redirect, right? But I don't remember.
It's a redirect, yeah.
Redirect. People use it for forwarding. So if an old URL you want to redirect to a new one, you can send a 302 and then with the update.
Permanently moved? Yes!
So that's one. Yeah. Cool. All right, we're good. So see what the voting is. Oh wow. Okay. 1984. Interesting. Good. Off we go. Which one of the following is one is missing? Is not an HTTP method. No internet, please.
Yeah, it's long enough for someone to really quickly Google it.
Yeah, it's long enough. Okay. So that right. So who would have guessed that? Well, in fact, I was playing around with the standard a bit, or looking into the standard. There's way more methods than we usually use, right? So the ones we are acquainted with. What are the ones we're usually using?
Get post.
Get and post. Yep. Cool. Anything else?
Delete.
Delete. What else? Put. What is put for again?
Inserting stuff. So we could have, I guess we could have used it as a replacement for registering webhook, for instance.
Yep. So yeah. So it's generally used if you changing a particular entity that's already registered on the server, right? So that's the put one. So
put is like update, kind of.
yes, exactly. It's like in a CRUD from a CRUD primitive to the update primitive. That's right. Cool. So remove doesn't exist. It's basically delete, right? Instead, right? Cool.
If you need to test many different services, you can use head, so you don't get all the data, just to
Does
check
the
that
header?
everything is okay. Yeah.
Yep. So that's the idea. Cool. Yep. And options. What was that about, or is that about?
Help, maybe? Like dash help?
Dash help for web services, right? That's a good idea.
That's a very intuitive.
That would be the helps method. Yeah. No. So no. What is it? Anyone? You? It's basically to find server-side capabilities that you can use. So protocol versions that are supported and so on. So again, it has some helping elements there, but it's more like
it was a good intuition.
So it's fairly close to that one. I'm not so much about usage, but about capabilities of that server you're interacting with. Yep. Cool.
So in our application, if somebody send options, we would give them back like a list of links they could use, for instance, and methods.
It would be more along the lines what HTTP protocol do you support, content headers and the like. So it's a bit more technical than that. It wouldn't be application specific. But the point is, it's open-ended. You can provide this. You're right. You're right. So you have some minimum requirements of information you need to provide, and you can expand it arbitrarily. Yeah? So it's open-ended. You're right. So okay, right. Next one. So for once you made it. So which one of the following is an invalid Docker command? So we have played around quite a bit of it already, and we'll see if I have an invalid one in here in the first place. Right. What's the issue? Who found the issue?
B instead of B.
Yeah, exactly. Right. So it's just I should have used the path here. Path here instead of cool. Cool. Did I forget to randomize again? Probably. We're nearly done, so you survive. Oh, it's only a fifth.
Oh, nice. Nice, you're done.
Security. Fair enough, maybe.
Det har ju bättre, mest bare
So that was the tricky one. It's just. Is anyone brave enough to indicate who was, the person that selected security? You. Right. So.
You could argue for it.
You could argue for it, please.
Well, you have economy of scales, you have secured premises, you can't beat Google, and whatever you do, you will not be as secure as Google.
Okay, interesting point. Right. Until they start hosting their service on AWS or what? Anyway.
Scalability is most important for us at least.
It depends on your business model, right? Perhaps you don't want to scale, you just want to have high availability in all different regions.
I just tapped on the left side of the screen.
I think there's no general, it really depends.
Those are, there is no single answer here.
Cool. Let's try, who did it? Root this time. Okay. Okay, difference Docker and Docker Compose. You notice there's pattern, obviously. Yep. Cool. That looks pretty good. No comments there, right? No. Quite straightforward. Cool. Good choice.
So, but one follow-up question on that one, like you can manage multiple Docker containers and arrange them, but you're still missing like the management of the management.
Yeah, we talked about this already.
Okay,
so that would be next level. But we didn't go and we don't. That's Cloud 2. Right. Okay. Okay. Which OSI layer is associated with the TCP protocol? In case you didn't get it yet, it's about networking.
There will be network questions on the exam.
Yes. We'll still talk about it in a second. But so what's the layer TCP is associated with? Cool. Sweet. So again, it's the transport layer in this particular case. What's the difference? Hey guys, few more minutes. What's the difference between internet and network layer? Again, just louder.
Internet is about addressing.
And the network one then?
It's about doing network stuff.
Okay. Right, okay, nearly there, yeah. Anyone else?
Does internet stand for internetwork?
Anyway, yeah, we know that.
So it's between networks?
Network.
Ah, okay, what do you mean? Okay, well, it's. I think we're putting too much philosophy into that. It's the same thing. So it's just in the Department of Defense model, the classical TCP model or stack. It's called Internet Layer, whereas in the ISO model, it's called Network Layer. So it's the same kind of thing. We'll see that in a second after the Kahoot quiz. I'll briefly run through those ideas. Yep.
Could you explain what the transport layer does?
Yep. So they, where the internet layer or network layer, if you like, is responsible for end-to-end connectivity, right? So this laptop to Google or whatever else. The transport layer deals with services on particular ports, right? So we're looking mostly hosting service on port 8080. That is transport layer information. The network layer is only interested in nodes. Yeah. So cool. Cool. Root is wow. Root is ruling, yeah.
New folder number 4.
Okay, functionality of the ICMP protocol. Again, networking. Hard, easy. We talked about this, in fact.
We did.
In one session, implicitly. We should have a confidence vote on this one.
Yeah.
So what is it? Oh, cool, cool. Yep. So yeah, so the what's the prototypical command that you associate with connectivity testing in ping, right? The ping command, connectivity testing. That's the ICMP protocol. It provides way more features, but that's the most prominent one that we actually use. So we ignore most of the other features they have. Yep.
Why a lot of servers
Good one.
disable ICMP and don't respond to ping?
Did anyone get this? Just to relay the question, Myers asked, why do many servers not respond to ICMP requests? Or
Potentially DDoS vector?
Yeah.
yep. So it's a good attack vector for distributed denial of service attacks. Right. Cool.
And how does it work? Like how you do a ping DDoS?
You just send a lot of pings from multiple containers. Or
Yeah. So you send a lot of large 64 kilobytes pings to a server.
Cool. No, we're not trying that now. All right, we're nearly done. So I thought, type 1 virtualization. Which statements are true? It's a bit of a Kahoot limitation, but we'll see. We'll see how many pick it. Cool. Yep. Good. See? Still consider a number.
Which statements? It's plural.
Yep. That's right. But so when one of the problems with Kahoot is you can't do an end selection. So it's not like you can't choose multiple options. So the idea is I left the space to decide which of them you think is the true ones. So you mean that I got it wrong in the first place, right? That's right. Thanks for highlighting.
Can't you have earlier this thing you had multiple correct answers?
Yeah, but it's only counted once for whatever you choose.
Yeah,
you can't
so
choose all of them.
You can have multiple correct answers, and if you choose one, it's correct. But he wanted to have that you have
compound.
to pick two.
Oh.
Yeah, no, and
Kahoot
connectivity.
doesn't allow you to pick two.
But now Amisi, what you said was, yeah, statements is wrong. It's in fact only one statement. That's right. So my apologies, typo. Cool. Yeah, so type 1 virtualization directly operates on the hardware, right? So basically the hypervisor is the operating system in widest sense, whereas in type 2 virtualization we have some operating system on top of it, the virtualization environment. Again, VirtualBox would be an example for type 2 virtualization, right? Because it runs on a given operating system.
Yeah, so one quick side note. So on a conference 2 weeks ago, I learned a cool thing. So inside an Intel CPU, you have to do, yeah, you didn't have operating systems. Okay, so anyway, so you have a CPU, and it has to take the instruction decipher it, put it into a pipeline, and then decode it into the actual operation on the silicon, and then execute it, right? And the management of that sequence is done by the operating system, which is inside the silicon die on the chip itself. And it's a fully functional embedded operating system that is based on Linux that runs shit inside the Intel CPU. And it's been there for years and years, and they've been like shuffling the silicon crystals around. So now, actually, nobody knows where it is.
What?
Yeah.
How?
And the problem is that, you know, it's another attack vector that you can attack if you're trying to, you know, hack somebody. And because they kind of are a bit of a messed up company, they are worried that they will have to redesign everything from scratch to kind of do a proper security checks on this.
How do you lose an operating system on a block of silicon?
You run optimization in the circuits, and they just shuffle it around, so they don't know where it is anymore.
Exactly, because it's been optimized and optimized and optimized for heat, you know. So now it's like all over the place, and they don't actually know where it is.
How do you lose your operating system?
Well, just be happy that chose Linux, you know. Cool. All right. Solid lead for root here. Doesn't surprise me. What is thin provisioning? Oh, cool. Right. Yep. So, so thin provisioning. We talked about this. It's different from optimizing your applications. It's really more like the hardware side of things. The idea is there, and this is basically where the well, economics of scale hooks somewhat in. You can basically subscribe to more virtual hardware than you have physically available, such as in OpenStack, for example. Assuming we have 10, I don't know, 1 terabyte of physical hardware storage. Nevertheless, you guys could subscribe to 1 terabyte. What did I say? 10 terabyte. So let's say 1 terabyte. So you could subscribe to 100 gigabytes each, and nevertheless, we won't run into issues because most likely you will not use up those 100 gigabytes anyway individually, right? So you can. Your application is adaptive enough to scale up if you get larger data over time and so on. You don't need to reconfigure your system just to get more space. You just use more space. But based on the fact that it's very unlikely that you hit any of those boundaries, the provider can grossly over-provision in terms of hardware. And only when they actually need the hardware, they plug additional resources in, buy new hard drives and so on. So you can actually satisfy the over-provisioned space or CPU power or whatever other capability, right? So that's the key idea there. Yeah. So you can basically allocate more space than you actually physically available because you won't use it anyway. Similar CPU power. What I mean in most of your services are mostly idling anyway, so so you can actually just spin up pretty much an arbitrary number of CPUs because the assumption is that each service only has a single spike request but not a continuous load. If you do simulations or any form of number crunching, then you can calculate based on load levels, which will be like 70 or 200% or something. But right now we're dealing more with load levels of 0 to 10% probably. Perhaps it spikes to 50 for a few milliseconds, but that's it. So that's the idea there. Yep. Cool. Root is still leading. That probably may not really change anymore. Nearly final question. What's the purpose of a security group?
Oh, where is my Kahoot?
Cool. Right. So against the common conception, we had this multiple times in classes. Just to clarify, the security group, when did we use it, the security group? Does anyone remember?
for instance, when SSH, when you made a group for SSH so that you could connect to the port 22.
Yep. So that was important, guys. I'm not sure if you got this bit here, but the idea was they're not interested anyway, so I concentrate on the rest of the class. So the idea is that security groups in the context of AWS and OpenStack, we saw them both briefly in AWS, they just manage network access. They manage which ports on which machines can be accessed from which ports from which machines. For us, it usually meant, well, you know, allow access to port 22 on that particular host from anywhere. Yeah. So, but it's all about network traffic there. It doesn't control who can log on, neither does it control which files you can modify or access or directories and so on, right? Just to clarify this one. You have an...
Do you mean generally or in the context of OpenStack?
In the context of AWS, OpenStack, in the widest sense of cloud computing. If you hear security group there, it usually refers to those concepts. Yes, you can make anything out of it, but the way we used it here, of course, if I contextualize it too much, then it would give it away. But I just want to clarify it. Here it's about networking. It's not about users or authorization, and it's not about permissions. Yeah? Cool.
Yeah, so groups in the POSIX system are different than
Yeah.
this one.
That's
so
a different concept.
Yeah.
Cool. And the final one. What are the problems with cloud services? Can't be more generic, can't it?
Well, that one is pretty easy.
Anyway. Right. So. So I think everyone can feel fulfilled after that answer. So pretty much all those issues are issues. It's just the question what you emphasize most, right? What do you think are the biggest challenges for you adopting it? That's basically it, right? So all the stuff we talked about before, no surprises there. Who has won? Root. Okay, who's Root? If he or she wants. Oh, well, congratulations, well done. 11,000 points, wow, okay. Who is Mani?
I don't know.
Ah, you. Okay, you nearly made it. But more interestingly, who tried that here? Who is get/answer/LA? Ah, there you go. Well done. Congratulations. So, well done, all of you. Cool. But I think, yeah, so I guess your basic intuition of what the kind of stuff we have been talking about and probably think about asking you, we'll see about this. So, yep. Cool. Well done. Thank you very much. All right. Before finishing up, some minor tech things. One of the things that we still need to talk about is the how of cloud computing, right? We didn't really cover that, but implicitly. So the underlying tech, and it's fundamentally elements of networking and dealing with the hardware. Yeah, hardware there being mostly storage and processing, right? So obviously representation of memory and things like this. But virtualization is the way of dealing with hardware in the context of cloud technologies. And one of the things that you guys want to be roughly aware of is the OSI model. So for networking, so it's the standard reference scheme for network layers, and has been largely adopted in the TCP model or Department of Defense model in earlier iteration. And the idea is there that we have 7 layers that serve different purposes. Either represent the physical byte representation on the network, right? So zeros and ones and so on, and how they are delimited into frames, so network frames. Then we have the data link layer. It's just the representation of zeros and ones. Then we have the data link layer that identifies different types of networking protocols, like Ethernet, for example. What's another one?
Yeah, Ethernet 1, Ethernet 2.
Ethernet, yeah, Wi-Fi is another one, right? So it sits on top of it.
Yeah.
Ethernet,
Fiber.
So
protocol.
yeah. So generally, there's some hardware dependency in there. They're generally aligned with the properties of the underlying infrastructure, but it's not something we generally look at here, right? So that's more like an engineering problem.
There are also, like in data centers, because if you use pure Ethernet, you're kind of really fast, but it has a very limited, you have to use switches. There is no routing in Ethernet. You have to use a switch which directs where the traffic goes. You have routing here, but that is too big. So a lot of data centers are kind of having their own protocols between 2 and 3. They call them 2.5 protocols. So there is like a label switching protocol, which is called like 2.5, and it's kind of in between the layers. So you have, it's like Ethernet plus labels, and then you can do routing based on the labels instead of the actual Ethernet addresses.
MPLS, right?
Yeah, yeah.
Yeah, so it's a networking kind of thing. That's a big thing. Yeah, provider side issue there. So networking, as we talked about earlier, is the addressing, right? It's really about identifying hosts, simply speaking, right? IP addresses, stuff you know. On a data link layer, by the way, which addressing scheme do we have there that you guys know? Just MAC addresses, right? So those are the hardware addresses that are attached to a particular network interface. And then we have IP addresses. Here's transport protocols. So that's specific to the services that you're providing. So what transport protocols do we know?
TCP and UDP?
TCP and UDP purposes?
Oh, the differences between them?
The purposes of the respective transport protocol? Or properties, if you like.
Well, usually streaming data and just sending data that you want to be assured arrives.
Yeah, and which one is which?
UDP is the one that just streams,
yeah,
and TCP checks if you received it.
That's right. So in this case, in TCP, the check of receipt and sending and so on is done on the layer itself. In UDP, it needs to be done by the application that sits on top of it, right? So in this whole, higher up, please.
Is MongoDB a separate protocol since it's specified in the URI?
Yeah, but even if something is built on the UI, which layer are we talking about? UI, what does it tell you? What kind of services do you usually expect on the other side?
Applications.
Yeah, yeah, applications in the widest sense. But if we talk UI, or which layer are we talking about?
Further up.
That's right. So it's further up, right? Specific encoding with respect to the protocol that the application uses, right? So if you're talking about URLs, for example, you expect HTTP sitting up behind it, right? So it's an application level protocol. MongoDB, likewise, an application level
So it
protocol.
will be layer 5 or 6.
Somewhere there. Those are all obscured in the meantime and mushed into each other, so it's no...
This is very clear to separate, right?
So
is WebSockets, are they built on top of UDP or?
WebSockets?
Yeah, they build on top of TCP usually.
Yeah.
And because they're WebSockets, they usually build on top of HTTP, right? So you kind of on the lowest level, you're kind of dealing with sockets with transport layer, but then they are being kind of passed through browsers via HTTP.
Cool. So, but it would be good to have a base understanding of that model, and it wouldn't hurt even to know those 7 layers in general. I think beyond this particular exam, but more for your own career and theoretical background. Cool. Sweet. So some other aspects in terms of cloud computing we talked about was virtualization. There was the notion of abstraction raised here earlier in the very beginning of this session. That's very right. Virtualization is about abstracting the physical hardware away by having the notion of virtual machines that provide you with all the usual capabilities, processing, memory management, networking, access to storage, and so on. And we differentiate between type 2 and type 1 hypervisors, as we just explored. And it all operates basically on an infrastructural level. Looking at type 1 versus type 2 virtualization, the key difference being that the hypervisor either directly runs on the hardware or it has an intermediate operating system. But as we learned now, the actual operating system sits in the hardware itself, which doesn't really help our cause. But for the conventional use of type 1 suggests that we have a bare metal execution on the hardware by the hypervisor. And Docker sits above that. So we have the host operating system and specific libraries and so on. And Docker basically has this concept of virtualizing on application level only. It only encapsulates libraries and specific binaries and so on relevant for your application. You guys know that because you literally build Docker containers. and you have a starting point of what libraries are available, such as you know, a base image if you like. You add your additional modifications and then call this thing a container. But fundamentally, it's still running on the host operating system kernel. Yeah. So the kernel, the underlying kernel, needs to be actually compatible with Docker in order to allow the invocation of system calls in the operating system. So not all operating systems support Docker. That's one part of the reason for that. Cool. Sweet. So since we are probably running out of time, the other aspects we talked about is an OpenStack architecture. Here the idea is not to learn it by heart or know you know, in great detail, but rather to understand how infrastructure as a service systems are actually decomposed, right? How do you separate computing from storage, from networking, and from other secondary services such as identity management, which is dedicated, image service, which for example provides the base images for your operating system like Ubuntu or Fedora or whatever else you want to use, or Windows, and then the core components, computing, storage, and networking that are integrated using some sort of other dashboard component, Horizon called. You use that briefly on OpenStack. So basically underlying, every time you instantiate a particular VM instance, it basically retrieves the image from the image service, links it to the networking, allocates block storage on the Cinder component, and finally registered as a new instance, new VM instance, so we can actually use and access it from the dashboard. So it's all about distributing the virtual machine across different components so it becomes scalable. So you can independently scale those up based on demands. Yeah. So it's a kind of a loose coupling approach on infrastructure development. Any other comments there? No? No? Cool. So something about security concerns. I'm not going into that in great detail, but probably relevant the what in the why in terms, sorry, the how in terms of how do we actually deploy. Some considerations to bear in mind. We constantly talked about when we talk about cloud computing, we generally talk about public clouds. Yeah, things that are actually infrastructure you share with other tenants, with other clients, basically that host their stuff on AWS. And you're probably operating on the same physical machine. You wouldn't even know about it, and they wouldn't either. So, but sometimes one way of dealing with the policy constraints or compliance issues is to think about running a private cloud, and OpenStack is a precise example of that, right? So you can host it yourself. Of course, you could also host it and rent it out to others on a per usage basis. Then it's the public cloud. But since it's open source and freely available, like we've done here, it's basically considered a private cloud solution that we can host. And obviously, again, you can have hybrid clouds where some services sit in private area cloud solutions and the rest on public ones. Yeah, so we link them up. Obviously, has different advantages, disadvantages related to cost, privacy, security, compliance, and so on. I'm not going into those details. Looking at Docker, we talked about the principles underlying it. Know about images, containers, well, what they are and how they're different, how you create them, and how you would go about Dockerizing services and applications. So roughly getting the key idea of how that works. We learned this in class, and you hopefully applied this in your third assignment briefly. So some of the Docker principles is a simple use, be it the ecosystem, for example, Docker Hub. We briefly had a look at this. Maybe worthwhile playing around with this and trying it out, but it's a good way of exploring the images you want to use. And then the separation of applications into different services and having a layered-based approach. So we have base images, build on top of those, and yet build on top of those again. Note also, we discussed about two different ways. I will not go into that right now, but we discussed two different ways of creating images, just as a reminder, right? So one was more explicit, the other one was interactive in the console. And it's worthwhile bearing in mind that those are different in the way they should be used or not used in production systems. Yeah, Linux, we talked about POSIX. Permission system, that's what's the command that's associated with permission system, or rather commands?
chmod and chown.
Yeah, chmod, chown. What are they for? The specific.
For setting up which user owns the file and which users have the access to which files.
So yeah, so chmod manages access, chown changes ownership, right? So cool. So the other thing is knowing roughly the file system. Again, it's kind of part is reasonably standardized. It's slightly different across different distributions. That's the nature of different distributions, but it's worthwhile knowing about it, how to navigate it, and where do you, by default, find relevant files. For example, etc being configuration files, the home directory being your home directory, for example, right? So other aspects, package management, they are specific to distributions. We only used one, which was that one. Now we actually use two package manager.
We used the Snap and apt-get.
Cool. Snap and apt-get, yep, they are specific to
Linux.
Yeah, more specific.
Debian.
Yeah, Snap is, I think, very specific to Ubuntu, whereas apt-get is specific to Debian, right? Debian being the broader ecosystem, so the older Linux. Cool. We talked a bit about foreground and background operation, and I'm just bringing this up because you may recall when we ran Docker, you could run it attached, where you actually see the output on the console, or in a detached mode where it's running in the background. Yeah, just to understand those concepts, what it means running things in the foreground and binding, for example, your terminal, or running in the background, right? Because what do we call background services in Linux?
A daemon?
Yeah, cool. Yeah. So if you read daemon, like MongoDB, or MongoD rather, should be run as a daemon in the background, right? You can run it in your console, but then you run it in foreground, but you should actually run in background. It should be operating system managed, meaning it should come up with the operating system and shut down with the operating system, right? That's the conception of a daemon. Anything?
No,
No. Cool. And that's, I think, all we want to talk about here. Some, yeah, the stuff, how the permission system works, the file system hierarchy in Linux. Yeah, those were the basic aspects in terms of what we talked about. Any other things we need to mention? If so, we mention them tomorrow.
Yeah.
But I think we have
Most covered.
most important aspects are sufficiently and redundantly covered, so we should have a solid background, right? So of course, for your exam, you should bring your baggage in terms of what you learned during your actual assignments as well, right? So we didn't talk about Go, but you learned a lot about Go, and some of those iterations are relevant as well.
Yeah, refresh your knowledge about IP addressing, IPv4, and subnets masks.
As far as discussed, yeah. Yeah.
Will we have any like dummy examples or something that we can?
No, because
like,
the course is
practice
done first time. We don't. Have
Yeah,
to
that's
use.
why dummy.
Yeah, but we want to provide some example questions that you can, but not the full exam. It's not, that's simply too much. But
Yeah.
we give you an intuition what the questions would look like. I think that may be helpful.
Like at least like know what type of
Yep.
question, like what.
I think it's reasonable.
We can do it.
We can.
Thank you.
So he's usually the bad one. But so yeah, we probably
I share Simon's view that there should be no exam. We should just call you towards the end of the course at random time and ask you random shit. So then we can assess how much you've learned, right?
That's right.
So even telling you the exam is gonna be on that day is already too much.
That's right. Anyway, so cool. Right, we leave it at that for now, I guess.
Yep.
Yeah. Tomorrow, remember, please bring your group, coerce your group to join you, to being marked for the assignment 3, right? So, and please have it running.
Was there a standardized way